Hello everyone, this is Dr. Lennon, and in this section we're going to be looking at solving systems by substitution. We've already looked at solving by elimination, so let's take a look at what the idea is and how this method of solving is a bit different. So the idea here is we want to solve explicitly for a variable, either x or y, in one of the two equations. Then we want to plug that expression into the other equation to obtain a single variable equation. So let's go ahead and just dive right in with an example. We already know what these things look like. So substitution is something you use over and over again in math, so it's good to see it here, even if as I stated, I think the elimination or addition method is a bit faster. But let's suppose we have 4x plus 4y equals 100, and we have x minus y equals 5. So the thing is, it's easy to solve for x in the bottom equation. So that's what we're going to do first, solve for x in bottom equation. So we take x minus y equals 5. We add y to both sides. So we get x as y plus 5. Then what we want to do is we want to substitute into the top equation. So replace x in the top equation with y plus 5. And because it's being multiplied by something, namely 4, we have to put it in parentheses. Anytime you're doing something like that, you need to include the parentheses so that you remember to distribute. So we have 4 times the quantity y plus 5, replacing the x, plus 4y equals 100. So that is the so-called substitution step. And then we just solve the equation for y. So we distribute, we get 4y plus 20 plus 4y equals 100. So now we have 8y plus 20 equals 100. We subtract 20 on both sides. And so we have 8y equals 80, which means y is going to be equal to 10. Now remember that solutions to these equations are typically ordered pair, so you want to find x as well. And we remember x is just y plus 5. So x is 10 plus 5, which means it's 15. So the solution here is the ordered pair 15, 10. So that would be the points where the lines intersect. So that's the main idea with substitution. Usually you're going to use it if you see that one of these systems is easy to solve for a particular variable. Why don't we call that one just part A and make this a multi-part type problem. So B, we have here, we will have y equals 3x minus 2 and y equals minus 4x minus 16. So because y is solved for explicitly in both equations, we can actually just set the right-hand side of each equation equal to each other. So there's not too much work in doing the substitution there. We just say 3x minus 2 is equal to minus 4x minus 16, and that's because each expression is equal to y. So then we can go ahead and just solve, add 4x to both sides. So we'll have 7x minus 2 equals minus 16. Then we want to add 2 to both sides. So we'll have 7x equals minus 14, and then we divide by 7, and we have our value for x. X is negative 2, and then we plug that into either one of the equations. I'm going to plug it into 3x minus 2, so we get y equals 3, and then instead of x we now write negative 2 minus 2, so this is negative 6 minus 2, which is negative 8. So the solution is negative 2 comma negative 8. So pretty easy when both of them are set equal to y, which that does come up quite a lot because that's technically the slope-intercept form of a line. Okay, let's do a trickier one where maybe the elimination method might be preferable. So let's say we're looking at 7x minus 2y equals 12, and also 4x plus 5y equals 10. So again, in this one, it's not so clear what to solve for. Nothing is really easy, but this one is going to actually look like a great big mess compared to the other one. So this is kind of going to emphasize why the elimination method is usually preferred. But what I'm going to do is I'm going to solve for x in the bottom equation. So when I do that, I'm first going to go ahead and subtract 5y to get the 4x on its own term, on its own side. So I subtract 5y from both sides. So I'm going to be left with 4x is equal to minus 5y plus 10. And then I want to divide by 4 on both sides. So I just have x now on the left-hand side, but now on the right-hand side, I want to split that into 2 fractions. So I have minus 5 over 4 times y plus 10 over 4, which is the same thing as 5 over 2 as a simplified fraction. So then what we want to do is plug this into the top equation. So this is where it starts to look kind of ugly. So we've got 7 times x, which we're now representing with minus 5 over 4 times y plus 5 over 2 minus 2y equals 12. So then we want to distribute the 7, so we get minus 35 over 4y plus 35 over 2 minus 2y equals 12. And then what we want to do is eliminate fractions. That's probably the best way. So one way we can do that is just multiply both sides by 4, and they'll all vanish temporarily. So we get 4 times the left-hand side, and then we're also going to want to do 4 times the right-hand side. So the right-hand side is just 48, and then the left-hand side is going to be minus 35y plus 70 minus 8y. So our minus 35y and our minus 8y are going to come out to minus 43y plus 70, and that equals 48. And then we want to subtract 70 from both sides, and we get minus 43y equals minus 22. And then we divide by minus 43 on both sides, and that's going to give us our answer for y. So y is 22 over 43. The two negatives cancel. Whoops. And then we want to, again, plug that into the original equation to try and solve for x. So let's go ahead and do that. So we're using the equation up here above. So x is going to be equal to minus 5 over 4 times 22 over 43 plus 5 over 2. And then what do we get? Well, we can simplify here, cross off a 4 with a 2, and then cross off 22 and make that 11. And we get minus 55 over 86 plus 5 over 2. So that will come out to 160 over 86. If you get a common denominator, multiplying 2 by 86, you would get 190. Wait, hold on. So to get a common denominator, we'd multiply 2 by 86, which would be we want to get 86 as a common denominator, so you would multiply this by 43 over 43, and 5 times 43 is going to be 205, and 205 minus, 215, and 215 minus 55 comes out to 160. Okay, so that will simplify to 80 over 43, so that's our solution. So the solution is 80 over 43, comma 22 over 43. So that took quite a bit of effort, and we had to work with fractions, but let's just solve for x using this the addition method and see how much simpler it is. So compare to solving via the addition method. So we have 7x minus 2y equals 12, and we also have 4x plus 5y equals 10. Those were our original equations. So what we want to do is I'm going to try and eliminate y. So I want the same number in front of y but opposite sign. So if I multiply the top equation by 5 and the bottom equation by 2, I'll have minus 10y on top and positive 10y on bottom. So I end up with 35x minus 10y equals 60, and then 8x plus 10y equals 20. So if you add those equations together, the minus 10y plus 10y add to 0, and we'll be left with 43x equals 80. And then if you divide by 43, we get our value for x. So x is 80 over 43. And then you could solve for y the same way. So as you can see, the addition, or as it's sometimes called, elimination method, is much faster if the problems are not specifically curated for substitution. And then there's one other method that is sometimes talked about. So solving systems by graphing. So the basically you're just, the idea here is graph both lines and find the point of intersection. So typically, this is going to be not so accurate if you're doing it by hand. But very quick if you can use let's say a calculator or program. So you can either use something like a graphing calculator, or Desmos.com is a good site, and I'm sure there's many others. So let's revisit the problem we started with at the very beginning. One of the two. Let's look at, let's see this in action for the first example. So let's recall what that was. 4x plus 4y equals 100, and x minus y equals 5. So the solution we got here was 15, 10. So I've got desmos.com open here, so desmos.com, and you can just go to the graphing calculator. It's a nice graphing calculator program. And that's all we're going to have to do is type in both of those equations we were looking at. 4x plus 4y equals 100. And also our x minus y equals 5. So what we want to do is you can either zoom out or kind of drag and pull. You can click and pull and it'll move you in some direction, or you can zoom out to try and find the specific direction. But we see there's the graph of both of our lines now, and if you hover over the point or zoom in, it should show the point of intersection here. If you hover over it, yeah, so there's the point 15, 10, and that's all it takes to solve these things by graphing. So if you want to double check your work, you can go to desmos.com and find the answer to any of these questions very, very quickly. But that's all I really want to say about solving by graphing, because typically if you're graphing by hand, you know, your graphs are not going to be to perfect scale, and that's going to cause a certain amount of human error. This can be mitigated if you're using graphing paper or maybe a ruler to make your straight edges, but if you end up looking at systems of nonlinear equations, then these things are curved and are going to be more difficult to graph as well. So typically graphing I like to think of as a numerical style solution. Anyway, that's it for this section. This is Dr. Lemon signing off.